Okay. Good evening, everyone. I want to believe we can all hear me clearly, and you can also see my screen. Uh, there's some technical hiccups in the middle activity, so we're going to try as much as possible to make up for it. Right? So I would crave your indulgence to be very attentive and follow through. Thank you. In our last class, okay, so my name is Benjamin. And it's good to be here. In our last class, we had an introduction to this course, really, and contraction, something, right? And we discussed quite a lot. So I'm going to more like a run through, um, see how we can catch up with other aspects of this class. All right. Okay. So for those who missed the class last week, we already discussed a lot of the process of drilling and what the video time will not permit me to play that again for us. But this is what the explorer looks like. Okay, so quickly, what's happening there? A rotary, a bit or a drill bit. This is how this is a live example of a drill bit. Okay, this is what it looks like. This is what is driven down to the earth crust. We explain the process of drilling starting from the introduction to oil and gas and how it is and how um, exploration activities take place. Alright? Um, the exploration, during the exploration, we first carry out a seismic survey, in the process, we send in what seismic data to the first to the earth, and then feedback are gotten, which is received and interpreted by the seismic devices. Uh, and these data are also analyzed. Then we're able to get help area drilling, and we try to ensure that it is directly to the reservoir of resource to beneath the export. Okay. Um, Also, we make use of the data that we get from the lab when we take samples of this to the surface with really video that show what and also explain the whole process of the drilling. But I'll just run through it. Now, the drilling, some key points that we need to talk about the drilling mode. The drilling mode, now, first rock has to get out of the hole. As the drilling bit goes down the hole, I'm just trying to continue from where we stopped in the last one. What happens is that you have to carry this posture rocks because the drill bit, this teeth here in the previous picture, this is what puts the rocks as it rotates. It keeps rotating at very high speed. It cuts the rock or breaks the rock and is able to gain more entrance. But as it does that, what happens is that these cross rocks will be piling up within this region and they could be that's like an obstacle in itself also. They pose some kind of resistance to it will also affect the well. So we need to bring them out of the hole. Okay. Now also the hole must be what supported. So we use the drilling we the hole must be supported. The reason why supported the hole is that so it doesn't collapse and all the rest of it. Or what have you, or get refilled, backfilled. That's the word. We don't want to avoid backfilling of what we are already drilling. So we use what now the drilling mode. Now in this picture here, this is where you have the mud pump or the mud and the pieces usually around here. It was pumped. So here it is pumped into the well or the drilling or already creating, right? Excuse me. You can use water with additives as clay chemicals to affect the viscosity and heat transfer. All synthetic fluid will actually between started to use also engine. Then when we talk about gray screen, combined term for the gray stem and the beat. So the combined term for the gray stem and the beat is all for the drilling string, then string. Alright. So we have a part that is called the annulus, that's the outside the stem. That's where the mud comes from. Then you have the drill collar, thickness of those stems. Right? Then with the well casing, I'm just breaking them down. From that video you watched in the previous class, most of the time I'm not playing that right now. Now from the video you watched in the previous class, you remember that there's a point where we now start to the well casing. This is what it looks like. Right? The well casing is it helps to secure the well also from collapsing. Alright? Because you are drilling down so many feet, you discover that there is a tendency for such wells, for such well to collapse internally. Alright? So we put the casing there. So we drive in the casing. It's like a tube of steel. Alright? And it is sealed to the borehole cement. So we introduce cement around it. Between the casing and the soil, you have a cement that is also produced. So it allows to help us to prevent leakage, and also strengthen the hole. By strengthening the hole is a kind of reinforcement for the hole to avoid the reduce the probability of it um, of we having a collapse of software. Alright? Just to be able to see it better. Alright, now here you have the clearer view of how movement as a pump in cement pump out from the pipe to the hole to fill up. Then the derrick, I gave that as part of the assignment before. So the center you should define. So we talked about the derrick, the working area for all drill operations in land or at the sea. For instance, engines, fitness, casings, and storage. And the derrick is part of the part that is striking of that the derrick is that part that that puts up with like a metallic framework. And, and that's where so it helps to feed the casing string down the ball hole. Right? It's let me just show us the picture again. This is the derrick here. This is the derrick. Okay. So that's what it looks like. Um, then during drilling operation, the derrick also it contains the machine for turning the drill string and the injecting and collecting the ball. So the derrick is the shape is the framework itself that contains these components of the rig. Alright. Um, I want to talk about striking when the bit finally gets to the source or the reservoir. and it has to prevent. So please take note of that. I hope you can hear me clearly. I I hope you can hear me. I know there is no movement here. Okay. If you can hear me, what I said is that actually the question open. I said, what happens when eventually the drilling strikes or is able to break through the cross and gets to the source where there's oil? It usually can be very explosive, and when not properly managed, you can have what we call a blowout, or that could be disastrous fire outbreak. You know, it's usually like an eruption. So what we do is that we install what is called a blowout preventer. A blowout preventer. That is a device that controls and stops erratic pressure and prevents a blowout. Now, why does this happen? The fact is that these oil reserves or reservoirs, they are already confined under high pressure and temperature, very high pressure and what temperature. So the moment there is an opportunity for an escape, remember that we've already started drilling. So it means that from the surface, we already have the we already have an aspect for this crude and the gas to the surface. The gas alone. In fact, most times you see in some worlds there's also a provision for flaring gas because it is usually very difficult to even it is complex. Let me talk about it. So to contain the gases that we get this, this this work, it is a complex operation to contain the gas along with the fluid. So it can be installed what we call the blowout preventer. The blowout preventer, this is what it looks like. Alright? And when it is installed, it will help prevent um, a, a scenario where we have explosions or what have you. Now, the this other one here, this is an annular blowout preventer. And you have the head here, this is then you have the let me make it a bit broader so you can see it clearly. This is what it looks like, right? Depicting the closer chamber. The opening chamber. That opening chamber is for accessibility. So now, when you are going to let out content from that outlet, okay? So this blowout chamber keeps a kind of control. So you set this area here, you have some electrical and fiber optic or hydraulic control system that is mounted on the blowout preventer. Okay, and it can be activated manually with switches on the rig and in the rig floor. Uh, Usually, what we have on the blowout preventer is two types of operation. Not any, it can be operated manually or automatically. You understand? You know, it's operated automatically when the well pipe of the rig is badly damaged. When the well pipe of the rig where we are drilling this from is already badly damaged, you have to operate automatically because at that time it should not be um, safe or proper for you to be able to operate it manually. Manually will involve you having to make contact with the connection. You know. Now the block here is usually about 60 feet. That's about 16 centimeters. That's almost the height of a three-story building, correct? Or so um, it's about usually about that. So that's what it looks like. Um, okay, there's a fact I needed to talk about. The 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 massive piston that from this side too, they slam together usually to stop flow of oil or natural gas. Those pistons are the ones that once they slam, once they slam together, it regulates the flow of the oil and gas. Right? Some pistons are fitted with cutting edges to share through the drill and the drill pipe and the well casing if necessary. Not in all cases. And that's done. Okay? Then this part here is a flange, is a flange end of the blowout preventer, and it is usually riveted or bolted to the top of the well in the stuff on the steel floor. Usually bolted to the top of the well. Right? And this now forms what we call our well bed or the Christmas tree. Okay? So our well bed or the Christmas tree. Um, I want to believe you understand that properly. Then, quickly, what I'll do to complete this, because I'll do that to the next step. Now, this is a blowout preventer. This is when it is already mounted, and this is where it is like an annular blowout preventer. It's like a donut shape, you know, and it's still around the size of the pipe, and inside pressure is applying. So this is what it looks like with the cross section. Okay. So we also have a ramp block preventer. If we are assigning your assignment, just take note of this, write it down somewhere. Assignment number one, we are going to send it to the same way, engineering mark, JPCS, engineer mark, ENG, ENGRN, WER, ENNA@gmail.com. Sorry, .jpts, engineeringmath.jpts@gmail.com. Right? The name is OGN. Use the possible to name and to also take your center. I'll be the subject. And subject to remain let you understand the OGN 315, OGN 315. That's assignment 2. Okay. Assignment 2. The first question will is to explain the the whole process of exploration and drilling. Explain the whole process of exploration and drilling using the process flow diagram. Then crude oil, of crude oil using the process flow diagram. Okay. The number two, discuss on the types of This can explain. This can explain the types of blowout preventer. This can explain type of preventer. Number three, explain the concept of directional drilling. Three, explain the process of directional drilling. Then number four, outline outline the function of the following: drilling fluid, mud pump, drilling fluid, mud pump. Outline the function of the following: drilling fluid, mud pump, mud loggers, mud loggers, drill bit, drill bit. Then finally a Christmas tree. Christmas tree. Okay. I hope we've gotten the visit on the Christmas tree. Now, quickly, well intervention. Let me just talk about that. So, now, well completion and the well completion process. You don't need to panic. You're going to get this material at the end of the program to be shared. But hopefully, last for the end of this um, class, this whole class, online class. All right. The mounting of our Christmas tree is for our welfare in last event. So now help us to be able to channel these tools out to various or through various outlets as, as we have. Okay. Now this is what the Christmas tree looks like. It's an assembly of different valves. This picture here is a Christmas tree. Okay. It's an assembly of when we close up so you can see them. Right? An assembly of valves that are installed usually on the wellhead to control flow into and from the well. You know, once you've already drilled the well, we install this. So you can see all these areas here. There are valves, different valves that are, well, it looks like a Christmas tree. So that's where the eyes is the entrance. It's like a tree because I think it has different branches and the rest of it. And that's where the, we can either allow flow, um, any kind of flow into the water or flow from out of the water. You know, so it's called a Christmas tree, but it's a wellhead, alright, at the wellhead. It allows access for well intervention and also for pressure and temperature and for pressure and temperature monitoring. So from this area, we can monitor the temperature and the pressure in the well. Alright. Then also want to talk about well intervention. Equipment to use for well intervention. Well, the last assignment is to explain the process of well intervention. I'll just give you some highlights on that. The objective for well intervention is to simulate zones. Uh, um, um, so there are various objectives why we do well intervention. And the equipment we use are pumping, straight line, the electric lines. Sometimes the quality is not as much as it used to be. So, now the capacity may not be as it used to be now naturally. So in such a case, we might need to carry out for the well intervention. Now, in doing that, we make use of this. The objective is on stimulate zone fracture or exercise as the process. Now, another one is to repair or replace broken equipment. You know, if for instance any of the devices or the equipment have been some faulty, it may need replacement. So we do that by well intervention. Then another is to also replace equipment to optimize flow. Like when like I just said, then sometimes also remove debris and deposits because it's true they are bringing out. So most times it's someone that comes out with some debris or some deposits and all that, and they keep accumulating along the way. So we need to carry out what well intervention. All right. So that those are the basic objectives for our well intervention. All right. These are pictures of how they look like well um, where a well loses its integrity means that it is no longer able to deliver as it used to be. Some of it could be as a result of in fact most times it's as a result of poor maintenance and it could also be that there may have been some improper estimations or evaluation of the well when the certain survey is being done. So you discover that the next thing that may result in such well may be abandonment. Sometimes some companies do intervention, they now have to bring kind of try well or try to like we're trying to um, make the well generate or kind of push it to produce um, more of the product like the food oil in this case, you know. But sometimes some companies just sell off their wells to other private companies. Those ones will not invest in well um, in recovering software and then we have the well